If you are dividing something with more than one term, this is a binomial on top, it could be a trinomial. If you have more than one term on the top, we use the distributive property with division as well. Do you remember when multiplying, if you had 2 times x plus 3, that we drew these arrows? And that was the distributive property. And then you would get, as an answer, 2x plus 6. When you're dividing, you do the same thing. You would divide this one and this one. But the arrows don't really work very nicely. So what we show instead is we say the first one, which is the 4x squared, that gets divided by 2. And then we write the second term, which is 6x, divided by 2 separately. And then we've divided before, so we use the same ideas as dividing again. Can I simplify 4 over 2? It just becomes 2. What about my variables? There's no variables on the bottom, so I'm still left with x squared on the top. Can I simplify 6 divided by 2? That's 3. And then I just have that variable. And that becomes our final answer after we've divided. So it's like the distributive property. If you have more than one thing on the top, each one gets divided by that number on the bottom. You divide the 4x squared by 2, and you divide the 6x by 2. Have you ever done that with numbers? Here. You don't do it with numbers because often you would just add the numbers. But if I did 6 plus 8 and I divided it by 2, order of operations, what would you do first? You do the 6 plus 8, right? And get 14. This is how you would normally figure this one out. Oh, 6 plus 8 is 14. What's 14 divided by 2? 7. Good. We could have also, in real numbers, if you had wanted to, you could have divided the 6 by 2 and the 8 by 2 separately. What's half of 6? What's half of 8? 3 plus 4. You get 7 that way as well. But in algebra, we have to do it the second way because often our terms on the top are not like terms. Like 6 and 8, those are like terms. So we could put them together and get 14, and then 14 divided by 2 is 7. That makes the most sense. Very rarely we decide, oh, I'm going to divide the 6 by 2 and the 8 by 2. But in our example, the numbers that we have on top, 4x squared and 6x, those aren't like terms. So we can't simplify them. And if we want to divide, we have to use the distributive property and divide each of them separately. So there's always a couple of steps that we're going to show in our work. Okay? So I have this question, 5abc plus 15ab divided by 5ab. I look in my numerator, the top of my fraction, and I notice those are not like terms. Why aren't they like terms? Because the first one has a c and the second one doesn't have a c. So I can see that they're not like terms. So for our setup step, we rewrite the first one, 5abc, and say, I'm going to divide that one by 5ab. And we write our second one, the 15ab, and I'm going to divide that one by 5ab. And when we have a monomial divided by a monomial, and this was on your test on Friday, we simplify the numbers. What's 5 divided by 5? Close. You multiplied. 5 divided by 5? Oh. She went to the office. Is just 1. What's going to happen with the A divided by the A? They're going to cancel out. The B divided by the B, they're going to cancel out. What am I left with? Well, the 5s, basically you could have done a line through the 5s as well. Oh, thank you. You're just left with 1C for the first one. After everything cancels out in the second one. What happens when you do 15 divided by 5? 3. And my A's will cancel out, my B's will cancel out. I'm just left with 3. So my final answer is 1C plus 3, or you could have just written C plus 3. I'd like you to try this next one. Your setup has 3 of them. So your setup will have 3 separate ones. And you'll have to simplify each of those 3. So the reason that I get you to try it on your own was a perfect example was Logan started writing this out on his own, and then he had a question for the second one. And unless you try things on your own, you don't run into these questions. He said, should I write a plus sign or a minus sign here? And if you write a plus sign but keep the minus up here, it'll work out just fine. Now we can divide each one separately. What is 9 divided by a negative 3? That's subtracting. We want to divide. Well, first of all, what's 9 divided by 3 is 3. Will it be positive or negative when I have a positive divided by a negative? It'll be negative. How many x's are going to be left? There's going to be 4 x's left. Are they going to be in the top of the fraction or the bottom of the fraction? On the top. So we can just write negative 3x to the 4. When everything goes away on the bottom, it would technically be over 1, but you don't need to write that over 1. You could just write negative 3x to the 4. Next one, negative 3 divided by negative 3. They would just cancel out, right? When they cancel out, you just get a 1. So we can just go like, okay, those ones cancel out. I'm going to get a plus 1. And a lot of students like writing the 1 there just so that they remember I did the math. In the end, you wouldn't need to write that 1 there. But a lot of students like to just like, okay, I did the math. Negative 3 divided by negative 3 is 1. Positive 1, because a negative divided by negative is positive. How many x's are going to be left? 2 on the top, so we'll have x squared. Next one, 6 divided by 3. 2. And will it be positive or negative? So now we write it as subtract 2 because it's negative. And how many x's are left? 1. Put a circle around your final answer. And it looks pretty impressive. So we have 2 steps. We have the one step where we divide each one separately and then simplify them. I'll wait.
I did it. No, we have C-H-R-O-M-O-S-O-M-E-S.
16 divided by 4 is?
4.
4. The x's would cancel, the z's would cancel.
I literally got the answer right.
That one was just one thing divided by another thing, so we could go right to the answer. For the second one, you have to take that first step of rewriting things.
Wait, you're going too fast. What the hell? You're going too fast. We're going too fast.
No.
Why are we going so good?
Okay.
Why are we going so
That's what I said.
So we take the first step, rewrite them all over the bottom.
I looked away for 1 second.
super cringe?
Pay attention. I love you too, buddy, but okay.
So we have to do this extra step
Oh.
of writing them all over, and then
Luke, let's just do the backstreet.
we can look at each one
Backstreet Boys too.
separately.
Actually.
Logan, Cherish. So 16 divided by negative 4. It'll be negative 4. How many, there's A's on the top and the bottom. How many are going to be left, and where are they going to be?
2.
2 left, top or the bottom? Top. How about the B's?
Oh, you're going too fast.
1.
1 left, and it would be on the top.
Yeah.
There's only C's on the top, so they stay, and there's D, it stays. Term number 1 is finished. Term number 2, negative 4 divided by negative 4, positive or negative? Positive 1. So you can write that 1 there. You don't need to, but we do. How many A's are going to be left? 0 A's are left, so we can actually write that those will cancel out completely. How many B's are going to be left? 1. Where? Top or bottom?
He tried looking like you today. Okay?
We have 2 on the top. Luke, 2 on the top, 2 on the bottom. They will cancel out. And then 1C. The last term. Negative divided by negative. Will it be positive or negative? Positive.
Yeah, I mean,
That's a lot.
that's why.
28 divided by 4. 7. How many A's are going to be left, and where are they going to be left?
You're going too fast. You're gonna have to wait for me.
1A. And then how many B's are left? 5 on the top. And 1D.
Wait, you're going too fast. Yeah, he did.
Page 275. And I told you 6 to 9, right? Duncan's what I told you?
Yes.
And that's what we're going to work on.